Hello, everyone. It's nice to see all of you today. I'm Anil Kumar from Toronto. Uh, let's introduce ourselves. Let's begin with Akshit. Yes.
Hi, my name is Akshit Kandivanam. I'm here to practice advanced functions once again so that I can do my best next year.
Mohammed.
Hi, I'm Muhammad, and I'm taking this course to try to get ahead of my class next year.
Vishruta.
Hi, my name is Vishrutha. I'm in grade 11. I'm doing advanced functions in the summer to get ahead of my class in September.
Very good. Ankita.
Hi, my name is Ankita. I'm going to grade 12 in September. I just wanted to be ahead of myself just so when I'm in school, I know that these two courses are very hard. And so just to have an idea of what the course will look like and be ahead of myself as well as my peers.
Great. Hamza.
My name is Hamza. I'm currently in grade 10, going into grade 11. And I've taken this course to have a better understanding of the concepts that I'll learn.
Perfect. So I really encourage you, Mohammed and Hamza, being in grade 10, they have taken a grade 12 course, which is called Advanced Functions in Ontario. And not only that, the chapter which we are doing today is a part of advanced functions and also a part of calculus, which is one of the toughest courses being offered in Ontario. So I remember that while we are going through this lesson. Last class, we introduced you to the average rate of change, which basically is the slope of the secant line. And we are always looking at two distinct points on the graph of the function. And we are using the same slope rise over run formula. The thing is, rise is difference of y values, delta y. Run is difference in x values, delta x. In function notation, we'll write this as f of x2 minus f of x1 divided by x2 minus x1. Is this concept absolutely clear to everyone? Perfect. So that becomes the base, the average rate of change, from where we are going to move to instantaneous rate of change. I'll give you a very simple example. Let's say you are going on a road trip to Florida, right? Mohammed, you're going there, right? Let's say you're going on a road trip. I went to Key West. I drove from Toronto to Key West, right? It was a beautiful journey. Then when you look at the speedometer moving like 60 miles, 65 miles, right? So there you have speeds of 75 kilometers per hour. Beautiful drive. So when you see your needle at 75, what does that indicate? Does it indicate average rate of change or instantaneous rate of change? Yes. Anybody?
Sorry, isn't it instantaneous?
Yes, it is. It is the velocity of the car at that instance. You get the point. Correct. So that is the instantaneous rate of change. However, let us say you start from here, take a halt at the gas station. You have covered around, let us say, 100 kilometers, perfect. And you took about an hour, right? So then, overall, what was your average speed? You did 100 kilometers in an hour. Speed was 100 kilometers per hour. Will that be an average rate of change or instantaneous rate of change?
Average rate of change?
Correct. 2 points. We starting point and the end point, distance divided by time. Average rate of change. So that is what it is. When we were looking at the needle, 1 point, it is instantaneous rate of change. Correct. Well, that point moves as soon as we see it. So we say approximately because the needle is constantly moving. Correct. So whenever we talk about instantaneous rate of change, remember that we are estimating, we are not exact. So instantaneous change is always an estimate. With that, let's continue the lesson. So this is for you. Okay. So today we'll talk about first, again, average rate of change. Then we'll see how secant and tangent are related with one another. And then we'll move on to instantaneous rate of change. I will use IROC for instantaneous rate of change, just as we used AROC for average rate of change, correct? So IROC by interval method. Well, there are three different methods of finding instantaneous rate of change. One is called preceding method, the other one is following, and then we have a central method. So those methods we'll discuss in brief. The major thing which we are going to discuss is the difference quotient method to find instantaneous rate of change. And this is the difference quotient method which is always applied in calculus. In your curriculum, for advanced functions, we have very few examples where difference quotient method will be applied. However, it is a good time to master this technique as you're going to take calculus soon, right? So take care of that. We'll have few examples and test questions. When I say test questions, I'm telling you that these are one of the best questions from last 10 years which I've seen in the test papers. Even in our average rate of change, the questions which we discussed, they have been repeated a couple of times in last test papers, and therefore I expect you to get similar questions in your test paper, and I also expect you to perform excellent, right? More than 90% at least. Okay, now, Akshat, can you please read what have I written about the average rate of change here?
Yes, sir. Average rate of change is the ratio of change in the dependent quantity with the respective change in the independent quantity.
Dependent
it's just-
quantities are, yes, sorry.
It's
Dependent
delta y over
quantities,
delta x, right, sir?
yeah. So we'll just take a minute break, right? Wait. Somebody has come, so I'm just taking, because I'm recording this session, we'll cut it off. Come inside. बच्चे नहीं है? Okay. So anyway, Mohammed, this point is very clear. I'll cut it off. So average rate of change, as you see the formula, see it very carefully. It is same as rise over run, f of x2 minus f of x1 divided by x2 minus x1. This is what we did last time. So you did not really miss a lot. Okay, Mohammed? And we are going to cover this up here also. So once again, average rate of change is the ratio of change in dependent quantity with respect to the change in independent quantity. Independent quantities are written along the x-axis and dependent quantities along the y-axis. When we write in function notation, y is written as f of x. And therefore, when we say difference in y values, we say x2 minus x1. So average rate of change is change in y over change in x. That is delta y over delta x, f of x2 minus f of x1 divided by x2 minus x1. Okay, that is what it is. So let's move on and see what, well, here's a very interesting case. Let me just talk about this. We are talking about instantaneous rate of change. It is a tangent slope, right? How do you define a tangent? Anybody?
Sir, isn't a tangent any line that comes close, like very close to the graph, but never actually meets it?
It touches at one point at least, right?
Yeah, 1 point.
Okay. Yeah. Anybody else? Any other definition, please?
I think the tangent is when it there's like a circle and like the line only crosses on one point, it doesn't cross to two. That's
Okay.
what it is.
Correct. So we normally think that tangent doesn't really cross any other point on the curve. You can see here in the next example, we do have a tangent at a point, right? On this particular curve, at the point which I'm writing, let's say capital P, it is a tangent line, right? You see that? And it is crossing the curve at another point. So this definition of a tangent just touching at one point on the curve is not the right definition, right? So as we have understood, tangent basically is what? So if I draw a secant, let's say this is my secant, right? Secant will go through 2 points, correct? To get a tangent on a particular point, let's say point P, and let's say point A here, in that case, we have to bring the other point close, very, very close. That's the idea, right? So we bring the other point B very, very close, let's say B dash, so that it is extremely close. We can say that the distance between them is negligible, very, very small. That means delta x value is approaching 0. In that case, it becomes a tangent. Do you see that? So this becomes a tangent. You get the idea. So the secant where the 2 points are far away, where we say distinct points. When these points come close together, then the secant itself becomes a tangent, right? So basically, we are saying that this difference, which is delta x, is approaching 0, right? So that is the calculus definition. Approaching 0, we'll say, we'll not put that kind of a thing. They will say limit, right? So we will not use the word limit, but we will use the main gist of it. That is, that difference is approaching 0. Is this clear, right? Perfect. So let's move on from here. So here is what I was trying to explain, right? So what we have done here is we are going to see what is the instantaneous rate of change at a point on the curve. For simplicity, we have taken a very simple example, which is y equals to x squared, right? So we know that instantaneous rate of change is basically f of x2 minus f of x1 divided by x2 minus x1. Graphically, average rate of change is slope of a secant line passing through 2 points, correct? Now, instantaneous rate of change can be estimated as the slope of the secant line when delta x, the change in independent quantity, is very, very small. You get the idea? Then the secant becomes the tangent and we get the instantaneous rate of change. Is that clear to you? Right? So how are we going to do it? So, Akshat, I'd like you to read this paragraph.
Slope of a secant approaches the slope of a tangent when 2 points on the curve are very, very close. We say that when the horizontal distance between them approaches 0, the quotient of change in y to the change in x approaches slope of the tangent. So m of t, the slope of t, equals to delta y over delta x when delta x approaches 0.
Correct. So basically what we're doing here, we want to find tangent at a particular point where x is equal to 1 in this case, right? So we are looking into a graph, which is y equals to x squared, and we want to find slope of tangent at x equals to 1. So what do? We take 2 points which are far away, A and let's say P and Q, okay? So we are taking another point at x equals to 2, right? So these are very far away, right? 1 unit is a big thing. So the distance between the two, as you can see here, is x distance is this much. Is that clear to you? Which is quite a bit. So what we will do here is we'll bring Q closer to P. That means we'll reduce this distance. This distance is delta x, correct? As Q comes closer and closer, then slope of secant becomes slope of tangent. You get the idea? So basically, at present, the delta x is equal to 1. If I make this delta x equals to 0.001, in that case, we'll say it is a tangent. Is that clear to you? Correct? So, in a way, what I'm trying to say is the formula now becomes f of x value will be 1.001 minus f of 1 divided by 1.001 minus 1. Is this point clear to you? We just gave the coordinate points. X1 is 1 for us. Value of the function at 1 is 1 squared, which is 1, right? So that is f of 1. And we will calculate the value of f of 1.001. This point is very, very close where the delta x is just 0.01.
Wait, sir.
Yes.
I don't really understand. Can you explain it again? The tangent, or the tangent. Yeah.
Sure. Once again, here it is. This is the most important thing. Is that okay? So at present, my question is, I want to find equation. We'll find equation later for slope of the tangent line. Is that okay? At x equals to 1, this is my question, right? So what I'm doing here is that I took a point of x between 1 and between 2, right? So I've got the second point q at 2. So basically, if I find this slope, then it will be basically f of 2 minus f of 1, correct? Divided by 2 minus 1. I get slope of the secant, correct? Now what I'm doing is I'm just bringing it closer. So if I bring closer, it means instead of 2, I'm at like, let's say 1.5, right? So let's calculate at 1.5, right? Minus f of 1, that is my fixed point, over 1.5 minus 1. I'll again get Slope of a secant, correct? Because I brought it closer, right? So I brought it at 1.5. Is that clear to you? Now, I am interested in tangent, and I'm saying that this difference, delta x, should be negligible. So, okay, so I bring it so close to 1 that it is like 1.001. Do you get the idea? 1.001 is almost at p, correct? Minus f of 1 divided by 1.001 minus 1. And that becomes the slope of tangent line. You see that? You can go even closer. With this, if you calculate, you get correct answer to 3 significant figures, 3 decimal places. You get the idea? That's much accurate. Yes.
So this is the universal formula for finding the slope of a tangent, right?
Yes.
So
So
always
yes.
make x approach 0.
Difference, delta.
The difference of x, yeah.
Yes. If you want to find the slope at 2, for example, then check the point at 2.001, correct?
Right, yeah.
So now, I mean, this is just the starting, but is this point clear to everyone? Mohammed, is it clear to you? Since you missed the last class. So I think clear, right? Beautiful. So now let's move on. And I'm just sharing with you the same thing once again. Okay. So, okay. Hamza, can you please read this question? Example 1. Your Mike, you're on mute.
Sorry. Given the graph of parabola as y equals x squared, find the slope of this the secant between the points p1 and q2/4. Find the slope of the tangents at the point p1/1.
Okay. This is what we discussed, correct? So first thing you find the secant between the 2 points P and Q.
So you just find the slope between those 2 points, right?
Yeah. That is y2 minus y1 divided by this. So you applied the formula and got the result. And we know this slope of the line, which is shown here, which is shown in orange here, is 3 for us. Is that clear to you, right? Can you please further read here?
Secant is a line joining 2 distinct points on a curve. The slope of the secant line through P1/1 and Q2/4. And this is the whole calculation. To find the slope of the tangent and P, bring the point Q closer and closer to P. When Q is very, very close to P, then the slope of the secant approaches the slope of the tangent.
Clear?
Yep.
How do we bring it close? We just get the point close, right? So I'm following a method to do it, right? So how are we bringing it closer? So we have these 2 points as I saw to begin with. I'm bringing it close really means that the x value, we started with 2, right, for Q? So these are the values for Q, right? These are the values for Q. Is that clear to you? Q at 2, correct? So we calculated the slope, as you saw. Slope is x square minus 1 over x minus 1. Is this statement clear to you? X square minus 1 over x minus 1. Is this statement clear to you? Slope is what? Slope is f of x2 minus f of x1 over x2 minus x1, correct? So now, our point is 1, 1. Original point is 1. So our x1 is what? x1 is equal to 1. And therefore, f of x1 is what? 1 square, which is also 1, correct? And I'm taking the function f of x equals to x square. And therefore, we get f of x2 as x square. Is that okay? Any x value. Is it clear to everyone? Therefore, the formula is, because the function is x square minus 1 divided by x minus 1. Mohammed, is this formula clear?
Yes.
Perfect. So when we substitute 2 for x, we get slope 3. We just calculate. That is the slope of the secant line. So I'm now approaching, coming closer. So when I come to 1.5 and calculate the slope, I get a value, which is 2.5. I came closer, closer, and closer. What is happening to the slope? 2.5, 2.2, 2.1, 2.01, it is approaching 2. Do you see that value 2 here? 2.0001. 3 significant figures, absolutely accurate result for this, right? Do you see that? Even for 1.001, we do get 2.00. This is 3 significant figure or 2 decimal places, right? So if you use this, you get 2 decimal places accurate result. So if the question is find or estimate slope or instantaneous rate of change at a given point, accurate to 3 decimal places, you're going to use this 3 zeros and 1. You get the idea? Then you will ensure that 3 decimal places you have the accurate answer. If you use 0.001, you get a wrong answer. Is that clear to you? Very important, find points where many students are losing marks. Okay, so that's very. Now, do you see what I did? I used a point which was after this, right? So we call this following, right? So this is following interval. Do you see that following interval? So we found the secant slope and then reduced the gap between the two x values, delta x, made it approaching 0, but we approach from the right-hand side. We approach from the right-hand side, and therefore this method is called the following interval method. Is this clear? We could have actually approached from this side also, right? I could have taken a value which was like 0.9999, correct? And got the same result. That would have been preceding method, you see. But if I take this value and this value, then it becomes a central method, because then I actually took a point on right side and a point on the right side. So that becomes a central method. So not a big deal. All are kind of similar methods. They give you the similar result. Is that okay? But we have 3 different methods. And in the question paper, the teacher might say, use this method. Correct? Central method is normally used. Central method is normally used. Okay, I prefer preceding method because it's easier, right? Working with those values. Okay, now, Vishruta, I'd like you to read this example number 2.
The thickness of the ice on a lake for 1 week is modeled by the function T of d equals negative 0.1 d squared plus
d cubed.
Cubed plus 1.2 d squared
Okay.
minus 4.4 d plus 14.8, where t is the thickness in centimeters and d is the number of days after December 31st.
Correct.
The graph of the function is provided below.
Correct.
Determine the IROC 4 days after December 31st.
Instantaneous rate of change after 4 days, 4 days after December 31st. What does instantaneous rate of change mean? Now, this question has been there in previous test papers, so I just picked it from there with exactly the same values, right? Okay, and that's the graph for it, correct? I put it on the right side. Now, I'm going to show you 3 different interval methods. As you can see the names, preceding interval, following interval, central interval, right? I'm not taking 4 pages of your book to explain these methods, just one example and 4 statements will give me this particular method, right? So first, preceding interval. That basically means that on this particular graph, if my point is, let me make a bigger graph, okay? So we have this, let us say, right? So don't worry about the way it is. Let's say the point of interest is somewhere here, right? So we're just going. So when we go for method number 1, which is the preceding method, that means this is a point of interest. We'll start with a point which is on the left side, let's say A. Then we'll converge to this point, and that becomes the preceding method. Is that clear to you? So you'll make a table just as we made a table earlier. However, you're going to approach as here. We want to be at 4, right? Our case is at x equals to 4, correct? Since we are saying 4 days after 31st December, and this equation is up to from 31st December, right? So the independent variable number of days is 4 for us. So we have the value of 4. What is the number very close to 4, but on the left side? 3.999. Is that clear to you? If you want accurate to 3 decimal places, then you have to use 3 nines. Is this clear? 3 nines will give you answer accurate to 3 decimal places. So if A is my point, this point is A minus H, right? So this should have been on the top. Is that clear? This should have been top, and that should come here. You get my idea, right? So if this is A, then this is A minus H. Is that clear? And the following will be B, which will be A plus H, correct? So in the case of following, we'll have
I have
the
a question.
Yeah.
So if if a teacher just gives us a word problem, how are we supposed to tell if it's like an instantaneous? Because this sort of looked like an average rate of change type problem too. So how are we supposed to tell, like, you're looking at a word problem that it's instantaneous versus average rate of change?
Yeah. If you are asked for velocity, it means instantaneous rate of change.
Okay.
So those are the terms. Or very clearly, your teacher is going to write down average rate of change and instantaneous rate of change. And thirdly, he might say rate of change when the x value changes from 1 to 2. Do you understand? It means 2 points means average rate of change, correct? And says at x equals to 1. That means instantaneous rate of change since 1 point is given. Clear? So these are different ways of figuring it out. So it's not a big deal. Okay? Yeah. So anyway, but I typed it wrong. Preceding means before that, and therefore I have to take a point which is before that, right? And the following is after that. So the x value will be from the given value to something which is close by. We generally write h, where h is very, very small as compared to 1, approaching 0. Is that okay? So instead of delta x, I will be writing h, since in calculus we use h. You get the idea? So I'm kind of using both the terms, which you will be using in calculus, just to make you aware of that, right? So all of a sudden, you don't have to relearn all these things. Perfect. As the clear example clearly shows you, it is f of x2 minus f of x1. So we write t4 minus t 3.999, right? Divided by 4 minus 3.999. The same formula for secant. Calculate, substitute the value in this equation, right? Substitute the value in this equation and then get your result, correct? Calculate, you'll get your answer. 0.4. I just rounded to 1 decimal place. We got 0.4 centimeters per day. Is that clear to you? Similarly,
Sir?
Yes, sir.
Sir, so what we're basically doing is using the same formula as the secant, right? But
Yes.
we're just bringing the delta x very close.
Yes, yes. Because
Okay,
that is
so-
what tangent is. Yes.
Right. So, sir, you know how we have t of 4 minus t of 3.999, right?
Yes, yes.
If we were given, for example, like you know how it said determine the IROC 4 days after December 31st? If it said like 5 days, sir, so would it be t of 5 minus t of 4.999?
Yes, yes, yes.
Okay, okay.
Yeah, 4 is because of that 4, right?
Right.
Yeah.
So that's our base point, right, sir?
Yeah, that is your a value, x equals to a. So in general, x equals to a, right? So that is what.
Yeah.
Right? So I should write your formula here once again in that form, right? So we are saying the slope. Now, when I write m, take it as instantaneous rate of change, the slope, the gradient, which you have been talking about, correct? So f of a minus f of a minus h, I'm thinking that this is a smaller point, correct? Divided by a minus h. Is that clear to you? Correct? So basically, in the denominator, minus a will cancel. And what you get formula is basically f of a minus f of a minus h divided by h, where h is very, very small as compared to 1. That means h is approaching 0. Is that clear to you? Very, very small means approaching 0, at least 0.001. At least 0.001. Is that okay? So you should use this formula. You can now write down this formula for instantaneous rate of change. But it's the same thing. Perfect? Very good. Is this point clear to everyone? So we have also discussed all the three. Central method, have a good look at central method. So we are taking 2 points, t of 4.001, which is 0.001 on the right side, and 3.999, same units left side. And of course, then the denominator will be 0.002, not 1. Is that clear? Because we went both sides, correct?
I have another question.
Yes.
What decimal place should it be normally? Like you're doing 4.001 or
Three decimal,
4.0001. Well,
three
how many?
decimal places.
3 decimal places? Okay.
Okay.
Yes.
So for the central interval, the main idea is just to pick a very close point on the right and on the left, right?
Correct.
So it's usually like the preceding 999 and then the after 001, like that, right? Okay.
Yes. So these three have been made important just because you follow a particular book and they follow this method, correct? And the questions are based on that. Is that clear to you, right? Nobody else is talking about it. Let's be very clear about it, right? They just say difference quotient method or find instantaneous rate of change, right? They're not so particular, preceding, following. No. Nothing. Is that okay? But for you, it's very critical. Oh my God. Okay. Ankita, can you please read example number 3?
Sure. And if you're wondering why my camera is off, it's just because my laptop is slow.
Okay. No problem.
Given the graph of parabola as y equals x squared, find the slope of the secant between the points x equals 1 and x equals 1 plus h. Calculate the slope by taking the value of h as 0.001 and then 0.0001.
Correct. So it is the same question which we did earlier. The only thing is, I'm changing the terminology. I'm taking you to the calculus first chapter. So very close means it is only h away. So if one point is at x, the other point is at x plus h, right? Y value will be f of x and the y value will be f of x plus h. Is that clear to you? Very simple. And here h is approaching 0, means it is very, very small as compared to 1. Normally, we will take the value of h as either 0.001, that's the default value, or this 0.0001 if your teacher is saying correct to 3 decimal places. So 3 zeros, 3 decimal places. If nothing has been mentioned, you could use 0.001. Is that clear to you? But doesn't matter. Use using calculator. Use whatever. Okay, very clear. Perfect. So we have worked with this point P 1, 1. 1 square is also 1, therefore you get 1. However, if I make it 1 plus h, then the y value is 1 plus h whole square, correct? So these are now 2 points. So therefore, in the formula y2 minus y1, y2 is 1 plus h whole square and y1 is just the number 1. Denominator is difference of 1 plus h and minus 1. Denominator always will get simplified to h because that 1 or whatever it is, that gets cancelled away, right? You're just h units away. So that delta x is h. So denominator will be h. Okay? We are using only one side. It could be preceding or could be following, correct? So following method is normally used because it's easier to work with positive numbers, correct? Right.
Sir?
Yes.
So this would be the following method, right? Because 1
Yes.
plus h.
Yes.
Okay.
Following method, default method. Oh, sorry. Got it, correct? Following method will be default method and difference quotient is the ultimate default method. You will soon realize why it is required. Okay. So now, you know a plus b whole square is a square plus 2ab plus b square. So we expand 1 plus h whole square, 1 plus h whole square as 1 plus 2h plus h square, and we have minus 1 on the other side. Now simplify this, 1 and 1 cancel, correct? You're left with 2h plus h square in the numerator. Step clear, right, Mohammed? 2h plus h square, I have factored out h. So when I factor out h, what do I get? I get h or 2 plus h. Now this h can get cancelled. Do you see that numerator denominator? And we have simplified our expression. We get the result, which is the slope of the tangent, in this particular case, 2 plus h. Correct? Obviously, if I use h as 0.001, I get 0.001 type of accuracy. Yes? Plus h, right? So the answer is yes.
Sir, I get all of this, right, sir? But you see where it says 0.11, right?
Mhm.
So can you explain to me how we got the point P and point Q?
0.11 is where? Tell me.
You see where it says now
Oh,
P
0.11. P is 11. Okay. Let me see. Y equals to x square, right?
Yeah,
We write function notation, right? F of x is x square. So what is f of 1? 1 square, which is 1,
yeah.
correct?
Okay,
So
okay.
what is f of 1 plus h? 1 plus h square, right?
It would be 1.0001, right?
Yeah, because h is 0.001, right? Do you see that?
Yeah.
So we'll substitute that value and find. Is it okay? But
Okay,
anyway,
yeah.
what we have done just now is a general solution. Is this clear to everyone? So this is a general solution. With h. Is it okay? Correct? Now, you could substitute any value of h. They said 0.001 or this, correct? I know the slope is 2 plus h, right? H could be 0 also. You get the idea? But we are saying very, very close. So we'll write the slope will be 2.001 or this, right? You could also write h as equals to 0. Then you know that slope exactly is 2. Correct? Right? But remember one thing. If the paper says write to 3 decimal places, then you will write 2.001. You will take the value of h as 0.001. You will not write 2 as your answer. Correct? So these are very fine points. Now, if they say they do not mention how many decimal places, in that case, you will write slope m equals to 2 because if h is very, very small, it is going to approach to 0, right? So it is 2 plus h. H is 0, so we'll write this as 2 plus 0 or just 2. Is that clear to you?
So, sir, H is basically negligible, right?
Yes, and you can make it 0. Exact value. Okay, but whenever we talk about slope of a tangent, we say estimate, and estimation has got some tolerance. This tolerance is defined by the question, which is saying that we can only measure up to 3 significant figures or 2 decimal places. Then you have to write answer to 2 decimal places. You get the idea?
So basically, you can just make h0 because you're just estimating that the slope would near something. Like
Yes.
you would, so if it would probably be like 2.0001, but you're just
You write
estimating
2,
it to be 2.
yes. But if the
Okay.
question is telling you 3 decimal places, you have to write h value as 0.001. This is what I'm emphasizing. You get the idea?
Yeah, okay.
0.5 marks will be lost if you write 2 in that case.
So unless it actually specified, but if it just gave like a general question.
General 2, right?
Okay.
General 2,
Yeah.
right? So see this, see this, see this. Let's go back to this, right? So what we did was we came to 2, right? So what are we saying here? We are saying that here the slope of the tangent is 2 because it is approaching to 2, right? 2.001. If you from 3, it went to 2.5 to 2.2, 2.1, ultimately 2.000, right? So that means 2, correct? We are
But
approaching
like
the
you know
value.
how we did like I think it was our first unit and when we described the graph we would always say approaching infinity or something. We
Yeah,
don't
yeah.
have to write that here, right? Like approaching 2 or approaching 1
Approaching.
or
Yeah.
you know.
See, you can write 2. Approaching 2 or 2. Correct? You get the idea? That question will tell you exactly. You have to read the question properly. I can ask you the same question and give you 3 choices. One is 2, one is 2.01, one is 2.001, one is 2.0001. Now you have to read the question. What have I asked in the question? 3 significant figures, 4 decimal places. What is there written? Or nothing. Then 2 could be the answer. Any one of these could be the answer. You get the idea. That is concept. And university will ask you that. Your school may not ask this question. Is it okay? First year university. Now here, we have understood a method. This is called difference quotient method. Quotient means divide one thing by the other, correct? Delta y over delta x is a division, dividing the dependent value change over the independent value change. We call it quotient, and therefore, this method is called difference quotient method. Is this part clear to you? Once again, you can make a summary of what we just learned. We learned difference quotient method. Akshit, can you please read what's written here?
Slope of tangent on the curve f of x at x equals to a.
Hmm.
Consider a general point P of a f of a and a point very close as q a plus h f of a plus h.
Correct.
The slope of PQ would just be y2 minus y1 over x2 minus x1. So f of a plus h minus f of a over a plus h minus a. And that would evaluate to f of a plus h minus f of a over h.
Is that clear to everyone? So always denominator will have h, and only thing which you can add here, of course, is that h is very, very small as compared to 1. Or you can write h is approaching 0, whatever.
Sir?
Yes, please.
Sir, can you also say f of a minus f of a minus h?
Yeah, you can say. So
You can
that
say
will be
that too.
preceding. That will be preceding. So if
Right.
you use this f of a minus f of a minus h over, in that case, we'll have a minus h, and you get the same result, which is f of a minus h over h, right? Minus minus becomes plus. Is that okay?
So a is bigger, which is why h is on the left side, so we take it
Yes,
away from the right
yes.
side. Okay.
You could take anyway, right? So either way, doesn't matter. Now, it is important to note that sometimes you are restricted. Why? For example, let me give you an example, right? Okay, if I have a square root function, for example, right? If I have a square root function, which is kind of like this. Can you take preceding?
There's nothing behind 0, right, sir? So
You cannot take preceding. Do you see that? So in this particular example, you have to take following. You cannot take central also, right? Can you? If I say what is the slope at 0, you have to take another point which is on the right hand side of the curve. And therefore, you're using the following method, correct? Similarly, I could have an equation in which I don't have anything on the right hand side. For example, let's say I have this curve, right? And because the space is not there, let's say we have something like this, 1 over x. You remember that curve, yes? And if I give you a point on here, you'll prefer to take on the left-hand side. You get an idea. Sometimes there is a discontinuity or such a thing that you cannot move in the other direction, right? Is that clear to you? Okay. So there are cases where you would like to take only on the right-hand side. And now, let me give you one more definition, which is very critical at this stage. And this is a key thing, right? So remember, let's go back to the basic definition of slope of a tangent. So in this case, when you find slope, we write plus here on the top. We write m. If I have a square root function, let's talk about this. Let us say we have f of x is equal to square root of x. Is that okay? So what is the slope of the tangent at x equals to 0? And there is another statement, x equals to 0 plus. Let's answer these two questions. Okay, Akshit. First question, what is the slope of the tangent at x equals to 0? This is my graph, square root x. And what is the slope of the tangent at x equals to 0 plus? Tell me, what is the answer for these two? My options are does not exist, very large, tell me, or 0, tell me.
sir, I'm thinking for slope of x equals to 0, it would be very large.
And the other one?
For when it approaches positive infinity, right?
For x equals to 0, it does not exist.
Oh.
Why it does not exist? Let me explain it, because I actually did not explain that part. So when we talk about a slope, we should be in a condition to approach from both the sides.
Oh, okay. So we can't approach from the left side, right?
Yeah. Since we cannot approach from the left, we'll say it does not exist. It is a different story that you measure from right or left, right? Do you understand? So if I write x equals to 0 plus, I'm saying you have to approach from the right hand side, and that is what it is. It is valid statement and very large. because we have restricted the domain. Our domain is that x is greater than or equal to 0. There's nothing on the left-hand side of 0, and therefore it does not exist. Is it okay?
Sure. So when we say x is equal to 0 plus, right? Where exactly are we talking about it on the x-axis?
It is almost vertical. So on the x here only, so it will be like very vertical. Is that okay?
Oh, okay. Yeah, yeah. So the slope is infinitely large, right?
Infinitely large. So, but there is a difference. We have to say infinitely large. Still, it is not a real value. Still, it is not a real value. Do you understand? So what we are distinction is that it is very, very large. Is that clear? And the other one is it does not exist because you cannot take it. The distinction between these two values. Is that okay? Perfect.
Sir, just another confirmation. So when we say slope of x equals to 0 plus, right? So we're not talking about 0. We're talking about like 0.1 or maybe 0.
Yeah. We are talking about a point which is on the right-hand side of 0.
Right side.
But we have to only take from the right-hand side of the 0. It will make sense because now you can write on the value, right? So you write square root of let's say 0.001 minus square root of 0, right? It makes sense, correct?
Yes, it makes sense.
And you are divided by 0.001. It is correct, valid.
So it's just h. Your h value just is 0.0.
Yes, it is valid, correct?
Yeah.
And you'll get a value which is very large, correct?
Right.
That is what I mean to say. It is like infinitely large. But it is a valid value. Correct? But at 0, it is not defined because on the left-hand side, nothing is there. You cannot go. It is a vertical tangent otherwise, and which is infinite slope, correct? You cannot. So some critical points, and that is why this subject is tricky. You need to understand these concepts. Example number 4. Hamza, can you please read this example?
Consider the following: f of x equals to x cubed plus 1. Find the slope of the tangent on the curve of f of x at x equals a and x equals -1. At point q on f of x, slope of the tangent is 12. Find the coordinates of q and find equation of normal at q.
That is a real test problem. This is what you're going to get, correct? Hamza.
So
yes.
Yeah.
Yes. Continue.
At x, okay. Yeah.
First thing, this function is given to us as f of x equals to x cubed plus 1. We need to find the slope of the tangent on this curve at x equals to -1, right? Slope of the tangent means instantaneous rate of change. Is that clear to you? So the statement is very clear. At x equals to -1, so you write f of -1. I'm not writing general statement, which is already given here, right? Don't write limit. This is calculus definition. We say h is approaching 0. Is it okay? We'll avoid the word limit, which is the correct one. So we are writing a plus h. A is -1, correct? And h is, let's write 0.001. Is that clear to you? Minus f of -1 over h. Is that clear to you? Substitute the value in the equation, which is, you could calculate separate. You would calculate what is the value of f of -1. F of -1 is -1 cube plus 1, which is 0. Is that clear to you?
Well, I have a question.
Yes.
So at the top, your f of -1 plus 0.001. The 0.01 is the value of h, right? So why didn't you write h, the value of h at the bottom, 0.00?
Yeah, you could write, but that is because we are given a particular point, right? So why not go straight? It's easy calculation, right? You can plug in -1 plus 0.001 just in calculator, use it in this value, get the answer, right? Do you see that? Plug it in your formula and get the answer within one line.
Sir?
But
yes.
Sir, so what we would do is f of -1 plus 0.01.
Yeah.
minus
Because
f of minus 1, right, sir? Divided by 0
yeah,
0.00.
h is 0.001 for me. Yes.
Sir, when I did that, I get around 2.997.
Right?
So would that be a valid answer?
Yeah, that'd be a valid answer.
Okay. So it
You
would, I can, if it's not asking for like significant digits, I could just write 3, right, sir?
so yes, yes, you could write plus or minus.
Plus 3, sir. It's 2.997. So
Correct. That is the correct answer.
right, right.
That
But
is
if
the
it's
correct
asking
answer.
for like 3 significant digits, then would I have to say like 2.99?
Yes,
Okay.
yes. You got the idea, right? So you say
Yeah.
2.99, right? Three decimal places, 2.999.
Right.
So these three different answers depending on the situation. Correct? You get the idea, right? So, but part B is very tricky. Part B is the reverse calculation. It says what? At point Q on f of x, slope of the tangent is 12. Find the coordinates of Q. Now you have to derive your formula, right? Using the quotient and then get the value of Q as I've shown you here. This becomes your test question for now. I'm leaving this here so that after you try, you know how to solve it, and that is how you have to solve it. Is that clear to you? We are going to end our class at this moment. Perfect. And this is the last question which we have to do. So you have to solve this particular part of the question, A, B, and C. Part of the solution is given here. So here what I did was, I did all the derivation, did not go for direct, because in part B, I wanted to know what the formula is, right? And in part C, we actually have got 2 points where the slope is what was asked for. You get the idea. This is the solution I'm sharing with you. But I would like you to do it on your own. So that is the equation of the normal, which is given here as a part of the solution. Perfect. So rest of the questions we are going to take next time. So I'd like you to do this. We are going to end the class here. And before that, can you please tell me what did you, how was the class? What did you understand? So we'll start with Ankita. Ankita, can you summarize your learnings today?
For sure. So we did start off with a little bit of calculus. I'm not going to lie, it did look a little bit complicated, but I think the fact that we're learning all of this now, and I was able to understand all of the small details that you added into each part of the calculation. I think I would keep those in mind when I'm doing any like test paper or when we get into the first unit of calculus.
Perfect. Mohammed. Mohammed, can you summarize what did you learn and how was the class? No, I cannot hear you. We cannot hear you.
Yeah, can you hear me now?
Yeah.
I found the definition. You explained the definition for rate of change, and also the formulas for both rate of change and average rate of change. Also, I'm a little bit new to it right now, but I was sort of understanding how to find the equation of a tangent on a quadratic. So yeah, that's
Anyway, don't worry. I'll have an extra class for you. So we'll review this concept once again. But at least you are getting the gist of it. Correct? That's very important, right? So keep it in your mind that I'll definitely have another class with you since you missed one, and that will give you another opportunity to understand this concept once again. Is that clear to you? Okay, Hamza, can you please summarize your learnings today?
So I learned all about the tangent line, the preceding intervals, the following intervals, the equation of a tangent line, uh, and then how to actually identify if it's a tangent like word problem, like we talked about velocity and all that stuff. So I didn't really know that before, so that's kind of cool to learn.
Good. Vishruta.
In today's class, I got a deeper understanding of rate of change, the intervals, and it would look really complicated, but I feel like the lesson was organized, and so like it went deeper into the meaning of all of the equations.
Thank you. Akshay.
Yes, sir. So when I used to hear instantaneous rate of change in physics, my teacher never really dived deep into it, and he always told us that we would learn it in calculus, right? So I thought it was really cool to like get in a step into calculus and learn about the tangent and secant relationship, and of course the quotient logic, along with like the preceding, following, and center intervals. That was really cool. So I think I need more practice on it, but I'm gonna do the 30 questions here.
Do questions from your book. Please do all the questions from your book and then attempt my videos on this topic. You could always search for Anil Kumar, Instantaneous Rate of Change, MHF4U, Advanced Functions. You'll get so many videos on this. Perfect. The particular example where we left, try to solve that, right? And then check the solution, which I shared with you at the end of this lesson. We'll actually continue from here, many more questions to come. Perfect. Have a great day. Thanks a lot for today's class. All the best.
Thank you, sir.
Thanks.
Bye, sir. Thank you.